guys, welcome once more to another video in our YouTube channel. So I believe majority of you who are watching this video right now, let me be specific. If you're a Cameroonian and you're watching this video right now, I believe you must have seen this picture that is displayed to you on maybe someone's status, maybe or WhatsApp groups or Instagram, Facebook, on different social media platforms. Yes, because what happened today was that the Cameroon national team had an encounter with the Serbia national team in their group stage qualifiers for the round of 16. It was match day 2 and the match ended 3-3, and the scenario displayed to you was the second goal scored by Cameroon, which was scored by their number 10 shed, that's Vincent Aboubakar. So it was one of the best goals in the tournament, and definitely was the best goal of the match, and it came at the right moment. So when I watched the match, I just pictured a scenario maybe to create something, because maybe you might be wondering who created this. I actually created it, yes, and I shared, and the purpose was not the purpose of me creating this was just for fun. So but now the way it went viral, everybody was just posting it and laughing and all the rest. So I thank all those who maybe proposed their solutions to me. Yes, I thank you guys very much. It means you're very engaged and you actually see the beauty of mathematics. Alright, so in this video we are going to be solving a problem step by step. Alright, so the question reads: the figure below describes a situation that happened in the Cameroon versus Serbia World Cup 2022 match, which led to Vincent Aboubakar'S goal. The points R and L have coordinates 1y and the xy respectively. The ball O denotes the origin. Roman 1. Determine the equation of the lines OR and OL. Let the equation of the line OL be f of x, and let AOL be equal to the integral from 0 to x of f of x dx. Roman 2. Express AOL in terms of x. Given that x where x is different from 1/3 satisfies the equation tan inverse of x equal to half ln 2. Find the value of x, hence or otherwise determine the value of y. Calculate the area of ORLX. Alright, so I was very rapid in reading the equation because I want the video to be as short and brief as possible. Alright, so first of all, I want to thank all of you guys who attempted and sent me your proposed solutions. Yes, you tried actually. So so many comments came in, and I want to adjust some few things in the equation before we start. So basically we are solving a 2D system, right? And the general coordinates, they are x and y, so I cannot be giving the points again x and y coordinates, whereas we have the x-axis and the y-axis. So I'm just going to change the x and the y coordinates to b and a. Alright, so x will take the place of a will take the place of x, and b will take the place of y. That's what I'm going to do. Alright, so let's now come and indicate the various coordinates. R has coordinates 1y, so it becomes 1b. So the x coordinate is 1 and the y coordinate is b. What about L? The x coordinate is a and the y coordinate is b as well. So R and L have the same y coordinate. Alright, so we are going to begin with Roman 1 of the equation, which is asking us to determine the equation of the lines OR and OL. So we are going to begin with the equation of the line OR. We know that every line in the xy plane is of the form mx plus c. So I've specified that it is YOR because it's the equation of the line OR. MOR is simply the gradient of the line OR, and C is the intercept. Now let's analyze the equation together. You see that you see OR passes through the origin. Yes, it begins from the origin. So clearly the origin is has point 0, 0. So 0, 0 lies belongs to my line YOR. So it means when x is 0, y is 0. So with that we can get the intercept, which is 0. So the intercept is 0. Alright. So with that we can rewrite our line in the form YOR to be equal to MOR times x, where we need to get the gradient, and the gradient is change in y over change in x. So my gradient is change in y, which is b, minus 0 over change in x, which is 1 minus 0. So it means my gradient of the line OR is equal to b, meaning that the line OR is just b times x. Now getting to the line equation of the line OL, we have the same form Now we need to get C1. Since OL as well, it passes through the origin. Anyways, it begins from the origin. It means the intercept is 0. That's C1 is equal to 0. So our OL is also going to be in the form YOL to be equal to MOL times X. Now things start becoming complicated, because majority of all those who sent me their solutions and share their solutions to the different WhatsApp groups were not able to find the gradient of the line OL, so they just left it in terms of MOL. But follow this solution very keenly, because I'm going to show you some methods that we are going to use to get the gradient of that line. Alright, so I'm just going to depict that figure. So we have our O arrow, we have OL, then we have LX, then we have ROL. Now if I try to complete this figure into a quadrilateral which has right angles everywhere, I just call this arrow prime, right? Now let me remove these lines inside here. What do we see? We see a rectangular figure or a square-like figure, but depending on if I drew to scale or not, but either rectangle or square, because we have 4 right angles as we can see. A right angle at arrow prime, at O, at X, and at L. Alright, so clearly if a line runs from O to L, we call that line the diagonal of the quadrilateral, as you can see, and that diagonal line gets the angles at O, the angle at O and the angle at L into 2. The angle at O is 90, so if a line is leaving from O to L, that line is going to pass through the center. Yes, it's called a line of symmetry, because it divides this figure into 2 equal parts, definitely into 2 equal right angle triangles. So it gets the angle at L into 2. 90 into 2 is 45 and 45, and gets the angle at O into 2, 45 and 45. So this angle here is 45. Now that's going to help us to determine M, because basically the definition of the gradient of a line, that's the angular coefficient of a line, is the gradient, and it is simply the tangent of the angle that the line makes to the positive real axis. That's its definition. Alright, so from normally we can get MOL by the definition changing y over changing x, right? Changing y is b minus 0 and changing x is a minus 0, so we get b on a. But what's the tangent of this angle here is still the gradient, and the tangent is b on a, because it's a right angle triangle here, as you can clearly see, whose opposite to 45 is b and adjacent is a. So the tangent of 45 is b on a, and we know what the tangent of 45 is. Tangent of 45 is 1. So tan 45 is b on a, which means 1 is equal to b on a. So with that, it means our MOL is equal to 1, because our MOL is b on a, and here b on a is equal to 1. So with that, it means we have gotten the equation of the line YOL to be x. So with that said, we can conclude by saying the equation of the line YOL is x, and the equation of the line YOR is bx. So hope you guys have now seen the trick that was there in the equation. Okay, so here I've replaced the x with a, yes, so that we should not be confused. So anyways, here is supposed to be a as well. Given that a, where a is different from 1/3, satisfies the equation tangent inverse of a is equal to half ln 2. So like I was saying, so we should not be confused. Alright, so Roman 2, we need to express AOL in terms of a, and first of all we have that the equation of the line OL is f of x, and AOL is equal to the integral from 0 to a of f of x dx. So expressing AOL in terms of a, first of all, what's my AOL? The integral from 0 to a of f of x dx. And previously we got the equation of the line OL as YOL equal to x. So it means my f of x is x, meaning that my AOL is simply the integral from 0 to a of x dx. We can integrate x, we get x squared divided by 2, and then we fit our limits from 0 to a. When we fit 0, we get 0, so we just need to fit a. We are going to get a squared divided by 2. So we have succeeded in expressing AOL in terms of a. Alright, now Roman 3, we need to find the value of a, but we have an information. Given that a, like I said, is not supposed to be x, it's supposed to be a. Given that a, where a is different from 1/3, satisfies this equation, we need to get the value of a, and then later on we deduce the value of b, or we use an alternative method. So we are actually going to use both methods. Alright, So finding the value of a, first of all, what's the definition of tangent inverse of a? Another trap. Tangent inverse of a is half times the ln of the absolute value of 1 plus a over 1 minus a. Many people who sent me their solutions excluded the absolute value, and I'm going to show you what is going to happen at the end when you exclude your absolute value. That's why they were not able to continue they were not able to continue the equation. Alright, so that's the definition of tangent inverse of x. So tangent inverse of x being equal to tangent inverse of a being equal to half ln 2. It means that half ln 1 plus a on 1 minus a in absolute value is equal to half ln 2. The half cancel the half, and then we get the lns to be the same. If the lns are the same, it means that their arguments are the same. So 1 plus a on 1 minus a, which is an absolute value, is equal to 2. We can cross multiply with the absolute value of 1 minus a, and then if you solve this, you are going to get two values of a. A will give us 1/3 or a will give us 3. How do you solve this? You can square both sides. There is no difference of 2 squares on both sides. You're going to get two values of a. The first value will be 1/3 and the second value is going to be 3. But if you use this tangent inverse of a without the absolute value, you're just going to get a to be 1/3. And I gave a condition that a should not be 1/3, right? Because if you look at where a is now, 1/3 is even between 0 and 1. So a cannot be in this interval, and look at the position of a. So a can never be 1/3. That's why I restricted 1/3. But people solved without the absolute value, which is a big mistake, and had a to be 1/3 and could not continue because the equation told them that a should not be 1/3. So they were like, the equation has a problem. So hope if you did that, hope you now see where your error is coming from. Alright, so solving this, we get two values of a. A should be 1/3 and a should be 3. But since I denied a to be 1/3, as the equation says, it means you are going to take just a to be 3. And clearly 3 makes sense because 3 is greater than 1. 1/3 is less than 1. But from your picture, we can see where a is greater than 1. 1/3 is less than 1, so a cannot be 1/3. So a being 3 makes sense. So we have succeeded in getting the value of a. Now let us see how we can get the value of b. How do we get the value of b? First, I'm going to use the hence method because the equation says hence or otherwise. If I said hence, maybe many people are not going to see what I'm talking about. That's why I say otherwise, so you can use an alternative method. If you are preparing for any exam, maybe the GCE or any exam, right, and you see hence, if you see hence, it means that you need to use the previous information that you had. If you don't use the previous information, then you are not solving the equation. But if you see hence or otherwise, it means you can use an alternative method. That's the otherwise part of it. So I just decided to say hence or otherwise, so that if you don't picture out how to use hence, you can use otherwise. Nevertheless, I'm going to use both methods. So using the hence, right, let us picture this. Now come back to, that's why I left this I still left this solution here, so that we should see the definition of what an integral means. Basically, an integral is simply the area under a curve. So the integral from 0 to a of f of x, the x is simply the area bounded by the line OL in the interval x equal to 0 right up to x equal to a. So that's, this integral just defines the area bounded by this line. And the area bounded by this line is simply the area of this right angle triangle. And what's the area of a right angle triangle? Half base times height. What is the base? The base is a and the height is b. So the area of the right angle triangle is AB divided by 2, half base times height. Alright, but since previously I have the value of a, right, the value of a is 3, so it means I can get the area. I can come here to get the area itself as a squared divided by 2, which is 3 squared on 2, which is 9 on 2. But since the area is still AB on 2, I'm going to replace the value of a with 3. So 3b on 2 will give me the very 9 on 2. 2 cancels 2 because they have they are the same. We can now divide all through by 3 to get b. So we are going to get b to be equal to 3. So that is using the hence method. The hence method, we try to relate the area using integration and the area using the formula. Alright, using the otherwise method, right, this is what we are going to do. Since we had tan 45 degrees to be equal to b divided by a previously, it means that b is equal to a equal to 3, right, because tan 45 is 1. That's using an otherwise method. So this one was directly. Yeah, you can use an otherwise method. And I think in the previous slide we saw that tan 45, which is 1, was b on a, and tan 45 is 1. So if 1 is equal to b on a, means b is equal to a. But previously we had a to be 3, so b is equal to a equal to 3. So I think we can see now that the figure is actually a square, right? Because if a is 3 and b is 3, it means that the height here is 3, and the base here is also 3, so the height here is 3 and here is also 3, so it's a square. Alright, now last part of the equation, we need to calculate the area of ORLX. Now what's ORLX? I'm going to depict the figure. You see that it is simply what we call a trapezium, right? And how do we get the area of a trapezium? We take half times the sum of the parallel sides times the height. What are the parallel sides? The parallel sides are RL and OX. Those are the parallel sides. What is the height? The height is from R to the x-axis, which is simply b, because this height here simply represents b, because it's the same as the distance from L to x, and it is b clearly. Alright, so this distance here is the distance of RL, because we need to take half times the sum of the parallel sides times the height. We know the distance of the height already is 3 because it is b. What about the distance of this other parallel side here? Because we know the distance from O to X, because O to X is parallel to RL, right? So we need the length. O to X is simply a, because O begins from 0. So O to X is simply the distance a, which is 3. Now what about R to L? Now since this is 1, right, and this is 3, how do we get this distance? The distance from 1 to 3 is 2, right? So it means the distance is 2. Now our vertical distance is 3 because it is b. Now the area of that trapezium is simply half times the sum of the parallel sides. The parallel sides we have LR or RL plus OX, then times b, which is the height. So replacing, we are going to get the area to be 15 divided by 2. I'm going to use an alternative method so we are very sure that the area is correct. Now I'm going to consider this very square, though we see it as a rectangle, but permits me, it's actually a square. Now I'm going to try to do this. So just follow what I'm going to do. So if I shade this portion, right, we see that the portion I'm shading is actually, it actually looks like a rectangle. Yes, because this is a 90-degree angle here. So what I'm actually shading is a rectangle, right? So this is the base of the rectangle, this is the hypotenuse of the rectangle, and the height of the rectangle is also b. Okay, sorry, I'm not drawing very vertical, but I believe you're seeing the figure that I'm trying to depict. So that's a rectangle. The base is 1 because this distance here is the same as this distance up this way. So the base is 1. What about the height? The height is b, right? So it means the area of the area that I'm looking for, that's the area, anyways, the area of the whole square, right, is equal to the area of my trapezium plus the area of this my rectangle, of this my triangle. Sorry, I'm calling a rectangle a triangle. The area of this triangle, which is in I've demarcated that area in yellow. The area of that triangle plus the area of my trapezium gives me the area of the square. So it means the area of the trapezium, which is what I'm looking for, is simply the area of the square, which is AS, minus the area of the triangle, which is AT. Okay, what's the area of a square? Length times width. Sorry, side squared. Anyways, the length is the same as the width, so length times width is side times side, which is side squared. It gives us 9. What about the area of my orange triangle that I've demarcated? It's half base times height. The base is 1 and the height is 3. Half base times height is half times 3. Half times 3 times 1, which is 3 on 2. So subtracting 9 minus 3 on 2, the LCM is 2. 2 times 9 is 18 minus 3 is 15. So 15 on 2. So no matter the method you use, you're going to arrive at the same answer. So the final response for the area is 15 divided by 2 square units. Yeah, the units are very important. Alright guys, so finally we have succeeded in solving the viral math meme, let me put it that way, that was released today. So For those of you who have not subscribed to the channel, please endeavor to subscribe to the channel. When you subscribe, make sure you turn on your post notifications so that whenever videos are uploaded to this channel, you always be notified to come and watch. Make sure you like the video if the video is good. Make sure you comment on a video, give your reactions about what you think. Maybe if you want me to do more math funny jokes like this, just indicate in the comment section, because if you don't indicate, then it means I'm going to feel as if it was not useful. So try to indicate, so I try to do other things that are also going to make you laugh. Alright, like I said, subscribe to the channel, share the video with your friends. Yes, share with your friends, share with other people who maybe saw the meme and have not yet gotten to the solution. I'm going to share the video to the various groups, WhatsApp statuses, Facebook, so it also goes viral. Alright, make sure you share the solution here so that it will also go viral. Thank you for watching and see you in the next video.